recording on this computer. Here we go. All right, so I'll go ahead and record this meeting just so we can fill in the Gaina box and Emily whenever they get back. So if you guys could go ahead and open up SolidWorks and make sure you have some kind of internet connection, because we're going to be pulling up some parts from some websites, and I'm going to be showing you which websites you want to be using whenever you're doing this. And if you have any questions, please say them in the chat. I'm not sure I'm going to be paying attention too much, but I'm sure Ryan will be able to answer any questions you have. So you can also just turn on your volume and just ask a question. And then, because chances are someone else might have that question too. So we'll go ahead and we'll make a simple part. I'm just going to make a cube. Oh, all right. I need to actually hide. Can I hide that? Nope. Because I need to view this right here. You probably can't see it. Oh, hey guys, there you are. You guys got your dog back?
Yep.
Awesome. That's super good news.
Good, thankfully.
All right, so right now, for some reason, my computer always defaults to this custom, and anytime I set the custom, it doesn't change it. So every time I make a new part, I have to change it to inches, pounds, and seconds. This is the standard that we use in FRC, and that's what we're going to be using for our competition. So we're going to go ahead and make our part here. It's just going to be a rectangle. I'm going to say that's 2 by 2. And we're going to make it 2 inches tall. Okay, so here is whatever part this is. Now, what I'm going to want to do, I have to move this again. Can I move this HUD? Hide video panel. No, hide floating meeting controls. There we go. Okay, cool. That works much better. Right, so we have our part. Now what we're going to want to do is we're going to want to make an assembly from this part. So we're going to go up here. We're going to go down to make assembly from part/assembly. And we're going to save and insert it. So I'm going to make a new folder in documents. Just going to call it F4 for now. Wonderful. And we're going to call this training part. I hope I didn't mess anything up there. And now it should be making my assembly. So you can see right here. All right, so here we go. As soon as you start this, instead of whenever you start a sketch and it asks you whatever plane you want to do it in, instead what we're going to be doing is on this left side here, you can see it says begin assembly. And so I'm going to just insert my training part right here. And as soon as you click it down, it'll be right there. And then we can go back to that tab if we go into insert components right here. And then it'll be whatever open documents you have, or you can open up another file that you have. And then you can put that in. And then if you want to put in multiple parts, you can put down this push pin right here. And you can go ahead and add multiple things in. Am I going too fast? Escape. Chat. Am I going too fast? Is everything good? Let me know in chat, or just unmute yourself.
Yeah, everything's fine.
All right, cool. panel. There we go. All right, so now that I have these three parts, they just can kind of float around. And if you want to move these, what I like to do is I like to select them, I right-click them, and then I go down to Move with Triad. And what this is you can rotate, you can just move it, or you can select this ball in the middle and you can change where your focus is. So that's pretty useful for like bearings and things whenever the orientation can do some wacky stuff, but usually that's just me playing around with things before I actually do work. But it's a useful thing to know. So the way we actually make things fit together is using what are called mates. So if we go ahead and select that, you can see that this toolbar is going to pop up. So I can select a point, I can select a line, an edge, or I can select a face. I can also select a whole body, I believe, but we don't typically have to do a whole lot of that. So what we're just going to be doing right now is selecting a face, selecting this face, and I want them to join together. Now, what I'm going to be using for that is coincident. If I wanted to just have them parallel, then it would make it to where this angle and this angle, these lines are obviously parallel right there. And I wouldn't be able to
Pronounced
rotate
coincident.
that. Thank you, Ryan. Coincident. I say coincident because I'm right, and this is my video. Now, I wouldn't be able to rotate this at all. Then there's perpendicular, which is similar in fashion to parallel, except obviously perpendicular. And then there is lock. So if I have these at a certain distance, I could hit this and lock it, and these two will just stay like that. But ideally, you don't have to do that. And you can instead, one second, I have to undo stuff because I'm dumb. If I add enough mates, I won't have to use lock. And if I do enough mates in the right way, I'll make it to where if I need to go back and edit something, it's much easier and I don't have to unlock things and then set them up right and then do all these different things that would be annoying otherwise. So first, we're just going to make these two coincident and then make these two faces coincident. And then make these two faces coincident. And now that's 3 degrees. And whenever you try to drag this, let me exit out of this, it should say the selected component is fully defined. It cannot be moved. That is what you want. Now, we'll go over some of the mate things later. We'll go more in depth with all the different mate types. But this is the first one that I put down. I think it's the first one I put down. And you can see right here, it says float whenever I right click it. Now, if I select one of the ones that I put in later, it says fix. Fix is like lock. Float is like unlock. So if I unlock this, these are no longer fully defined. I can move them around a bunch. And if I undo that, you can see that the origin is about right there. That's because I put it in and then it locked it in that position. So the first thing you put in is going to be sort of locked in that position. And then other things you add are going to be free floating. But you can change what gets locked and what gets unlocked with the fix command. So if I fix that, it fixes its relative position to the origin. I don't know if you went over that in sketches, But in order for something to be fully defined, it has to have some kind of relationship to the origin. And so now this is fully defined. It says it's fixed, it cannot be moved. But this, we can move this. So I'm actually going to go back and I want to edit this part right here. And let's ignore the fact that I already have it open. If I want to open this, I can right click it and I can go up here, open part, or I can go over onto the side here. This is like my Explorer page. This is where I can see everything. And I can go right here. You can see this has an F right here. This means fixed. So that's my fixed part. And I can go over and I can change things, but I just want to open it. So it's going to divert me to my other tab because I already had it open. And now what I want to do is I want to make this one different from the other ones. Now, I'm not going to lie, there's a proper way to do this, but I really don't know how to do that. And every time I try to use it, it messes up on me. The proper way to do that would be, if these are very similar, is to have different configurations. Every time I try to play around with configurations, they always break and make everything the same for me, and then make some of them different features that didn't exist. And it's weird. I have to learn more with that. But for now, what we're going to be doing is we're just going to save as. Now, whenever you save as, there's 3 different options. One of them is basically overwrite this. The second one is overwrite it without changing the original thing. And the other one, and then leave it closed. That's like making a, the middle one is like making a backup. And then the last one is the one you had open that you saved from is the backup, and the one you saved as is now the one that you're opening. And basically, whenever I hit this one, it's going to open up the thing that I'm going to be changing. So we're going to call this changed training part. And then you'll see it should say changed training part. But I still have that open. Cool. So what we're going to be doing is I'm just going to make a hole. And I'm just going to put it right there. And it should be 1 inch. And then what's important is reference geometry. So this midpoint, actually, I can't do that, can I? Delete. Crap. Oh, no, I had to make a line and do that. Whoopsies. So I go up and I make that vertical, and then I do that and all that. And then we're going to say that's 1.5 inches. All right, there we go. So whenever you're designing your F4 piece, you want to make sure this shows up. You don't want it to look blue. If it's blue, it's not fully defined. If it's black and it's bold, then that means it's fully defined. This dotted mark, I'm sure you guys already know, that just means it's for, excuse me, that just means that it's for construction. It doesn't matter. It's not going to make any kind of feature cuts. It's mostly used for measurements and reference geometry. Excuse me. But you don't want blue. You want it to be fully defined. That way, if they ever go into one of your parts, they can see, oh, this is fully defined. This is a proper piece. So we're just going to go ahead and extrude a cut. This isn't really a huge deal. I think you guys already went through features, but there's some significant things to go through here. So blind is I set the distance. That can be pretty annoying if I change the thickness of this piece. So I'm just going to go ahead and do it through all. That way I can always change the thickness of my pieces. Then we're going to go ahead and save. And then we're going to go back to my assembly. But, uh-oh, I don't have that piece open. So I have to delete that. Yep. I'm going to open my change training part. And I'm put 2 of them in, and I can unpin that, and I can go ahead and check that box. So I can kind of move these how I like them. And now what we're going to be going over is circular mates. So I'm going to select these 2 right here, and what it's going to automatically default to is coincident. And that's because these 2 circles are the same size. If they were different sizes, then it would default to concentric. The difference is that coincident means that those 2 edges overlap and they stay like that. Concentric is that they stay as if there's an invisible rod that goes through them, and then you hooked the 2 of them on like beads. They're going to be on the same thing, if that makes any sense. The best way to picture it is just through this way. You can see that they're staying completely within one another, because if there were a rod that were going through that, then the rod would stay and the other pieces would just move around it. Now, concentric is often necessary because you can't always make things coincident and make it nice and handy like that. So if you make it concentric, what you have to do then is you have to, I'm going to go ahead and fix these. Check. We're going to go ahead and fix that. But we can, if we make this concentric, we have to define it in other ways. And so, like before, I'm going to add those 2 faces together. Actually, I'm going to set them a certain distance apart. And I don't know why it's in freaking millimeters. I freaking hate that. But we're going to do half an inch. And it shows it in millimeters. It's half an inch. There we go. So distance is very handy if you're doing something like spacers or wheels on an axle, things like that. Or if you're planning things out before you, oh, hi, Ryan. Ryan, it's been raised a hand. Crap.
Hey, Dan, you can change the default units used in your files in the bottom right corner where it says custom. If you hit that drop down menu IPS,
oh, thank you, Ryan.
that will change it for the assembly. All right, I'm going to get back.
Thank you. Ryan just say, oh, chat. I haven't been looking at my chat. All good, all good. He has to run soon. Do we have a GrabCAD folder set up for this? Not yet. Are there rules against pre-CADing? Can we have a generic? We can have a generic drive base ready. Okay, so let me just go ahead and answer that question fully. There are rules against pre-CADing, but it's similar to first rules in that it has to be publicly available beforehand. So we can't go ahead and start CADing a robot right now and like act like, you know, we did it beforehand. That's illegal. Or act like we did it during the competition. That's not allowed. It's not very JP. Don't pre-CAD. can we have a generic drive base ready to adjust quickly? Yes, we could technically if we change every single piece of it beforehand. I don't like that idea, considering we're going to be using this as a training for the build season. So we're going to act like we're hitting the ground, running, making as much as we can from scratch. I mean, we have a week. It's not going to be as much time as it seems, especially with school and everything. Now that spring break is going to be over as soon as we start it. But what I'm probably going to end up doing is just taking 2019's drive base or 2018's drive, or not 2019, 2018 or 2020's drive base, and just change the sheet metal, because I'm pretty sure those are either public or I mean, it probably doesn't matter if we just change it, because it would change every single part of it. But I don't like the idea of pre-catting. We'll just try to do as much as we can. Right, back to what we were doing. So we set a distance apart, and now if we move this around, we can see that it's still not quite the same. I could still, if I make this to this, let's go ahead and do that. I can still rotate this, and these can still move up and down. So this is still not fully defined yet. So I have to go ahead and I have to make that coincident. I have to go ahead and I have to make that coincident. Then I have to make that coincident. And so now you should say this selected component is fully defined. It cannot be moved. I win. All right. So there's some very, 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 very basic assembly things that you can do. I think there are some other mate types. There's tangent, but we don't use tangent a whole lot. That would be like if you're trying to put a bolt in a square hole and you need to somehow relate the bolt to the square hole. My best example of that would be Vex, but I think Sai and Ryan are the only ones decently affiliated with Vex. If you've ever seen it, there's square holes and there's circular bolts. But other than that, we don't really use tangent a whole lot. Maybe we'll end up using it this time around, but if you don't know what tangent means, is you can see kind of from this picture, it means that it's at a point on a, let me try to demonstrate this with a sketch. A tangent means that if you make a circle, make a circle on the thing, and then I have to, crap, and my computer's whack. All right, cool. Just do the thing. There we go. All right, so I have a circle. Now, if I have a line, and I say that it's tangent to a point on this circle, if I say it's tangent to the circle, that means that the point at which they contact, the radius is perpendicular to the tangent line. So let me go ahead and draw that out. If I draw it to where it's right there, it's, if I make it a radius of the circle and then I make it to where it's perpendicular to the tangent line, you can see that that's a single point right there for all of those. So that was a bit too in-depth of a guide into what tangent means, but I went off on a tangent about tangents. But now what we're actually going to be doing is we're going to be looking into what you'd be actually doing. So I'm going to go ahead and open, what can I open? I'm probably going to open up, where'd that thing I was working on go? I'll just open up something like this. And we'll pull up the, oh, I suppose you guys probably can't open one of those parts either. Okay, we're going to go ahead and make one of those parts. So we'll just look at this right here, and we're going to go and edit this feature. Actually, no, wait, it's not the feature, it's the sketch. Sorry. All right, we're going to make this 1.125. Now you might know where I'm going with this if you're familiar with axles. And then we're going to add some holes sort of arbitrarily like this. And then we're going to make a square, the square, some reference geometry, always handy. Then we're going to relate this to center line, goes right there. Oh, Zoom says my internet connection is unstable. That's not good. Let me know in chat that I can't see if you're having a hard time understanding me. We're going to go ahead and relate these to where they are equal. You could also just yell at me. You could turn on your mic and just yell at me if I'm doing something and you just can't understand me. So we're going to go ahead and make this 1.5 inches. I'm going to make that right there. I'm going to drag that right there. I should relate that. Drag that right there. This is going to be 0.203. And then we're going to go ahead and we're going to make all these equal. All right. So now that we've got that, we can go ahead and make this some construction geometry. And then we've got all of our things. We can go ahead and features, it should cut through all. There we go. And then I'm actually going to change up. Actually, am I? No, I'm not. Yeah, this is fine. I'm going to go ahead and save that. And I'm going to open up chat. All right, are there any questions? Are you guys doing all right? Everything's good? You're all doing all right? Right? Okay, I'm gonna assume, yep, Thomas says yes, cool. So now that we're up to this point, what you are gonna do is going to, oh, I did not mean to do that. We're going to make an assembly. And we're gonna put in 2 of these. And to put in 2, we're gonna hit this push pin. We're gonna put in 1, and then we're gonna put in the other. All right, there we go. And so before we do anything, we can either relate all these together. But before we do that, let's just put in the parts that we need. So this is the part that is probably going to be, I don't know how to describe it. it's going to be a lot of your job. So I'm just going to open up a new page here. And I'm going to go to Vex Pro. So there's a couple things you want to go to. You want to go to Vex Pro, Andy Mark, and make MasterCar. So it's going to pull up stuff that I've already been searching. But Vex Pro, Andy Mark, make MasterCar. These are our three main vendors where we get our commercial off-the-shelf parts. And Vex Pro is down. I don't have internet. Cool. Awesome.
Chest kicking box.
All right, guys. So I think where he was going with that, he's coming. Dan, hello.
All right,
back.
can you hear me?
Yeah, wait, hear me right now?
Yeah, I can hear you.
Okay, I had a question in chat.
Oh, okay. What's up?
Okay, so do you want us to use that kind of reference tree whenever we're making our pieces for the catathon?
Yes. I don't want you to dimension everything out.
So rather than dimension all the different holes or use like a linear sketch pattern, you'd rather us do like a square and then have like the construction line still there and everything like that?
Linear sketch
Like
pattern's fine, but I don't
Okay.
want to see a bunch. Correction. I don't want them to have to see a bunch of just dimensions.
Yeah. Okay. Let's keep our design language, all that fancy word stuff, consistent throughout the entire
Yeah.
project.
So if you'll see in the Slack, I put out a thing. It's sort of like guidelines for whenever you make a part, and it's sort of like a checklist that you can look at whenever you make a part and double check everything is consistent. I just put some standards in there so we can sort of make everything look like it's cohesive. All right, but yeah, sorry about that whole deal. My connection just sucked for a solid second there. Let's see if I can reload this and my internet won't crash. It would probably help if I close some tabs. All right, so Vex Pro, Andy Mark, Make MasterCar. Make Master, you kind of have to know exactly what you're looking for, because like if you just looked up timing belt pulleys, you get all these things and you'd have no idea what we actually use are HTD pulleys, unless we use something else in a specific case, which is weird. But yeah, there's all kinds of things wacky with that. Andy Mark is also really annoying, because if you try to open up something, then whenever you look for the CAD, sometimes they don't even have the CAD. Like if I go to let's just open up some bearings. I want to grab a bearing. This is what they do. They give you a giant list of literally all their freaking bearings, and it sucks. I hate it. It's terrible, and it's bad. It's even worse with the freaking gears. I hate how they do the freaking gears, because there's a million different types of gears and a million types of gear diametrical pitches and all these freaking things, and it sucks. And don't use it. It's stupid. What I like to use is Vex Pro. Vex Pro is very nice and organized, and thank God for freaking crap, I can't remember his name now. The guy who came over, the 217 and 3310 guy, Paul Copioli. Thank God for Paul Copioli managing this. So what we're actually going to be doing is we're going to be going into hardware. And we're going to grab, actually, we need bolts, don't we? Actually, no, we need bearings. Do they have bearings here? Bearings. Bearings, bearings, bearings. There we go. We're gonna open up some bearings, and for bolts, we need to go to McMaster-Carr. So we're gonna go bolt. I actually like McMaster-Carr, how they do things. It's just sometimes it gets really, really confusing. Like you're never gonna use any of this down here ever while you're at Mars. You might use that, but you're never gonna use anything beyond this. So we're just gonna grab some socket head screws. Again, socket head screws. And we're gonna go back over to VexPro. And what we got, I got a 1/2-inch flanged hex bearing. So navigating VexPro, you've got your page right here. And here's all of your different things, and this is what you'd be doing if you were buying them, but we are not Earl, we don't have to buy them. So what we're just gonna be doing is, oh my God, why? Over here, this is what we use. We use drawings. It should be giving us drawings whenever we select this, or flanged hex bearings. It'll give us handy dimensions that we can use. So this right here, it's 1.124, but we do 1.125. And then we use, that's actually all we need. You might use the flange if you're trying to space things out. But then once you figure out what you need, go to your CAD files. And then this gets really confusing because then there's a bunch of numbers and you don't, flanged. Flanged bearing, right here, it says flanged, 1/2-inch hex inner diameter. The only difference is this says V2, this is normal. I really don't freaking care. I just want a bearing. And then we can go ahead and open that. And then while it's doing that, we can go over to McMaster-Carr, and we're going to grab steel socket heads. So now what we need, I put in 0.203. So if we go over to 1032, that is the 0.203 is the bolt size, is the hole size for a number 10. And 32 has to do with how many threads per inch. And seeing as our part is 2 inches long, we are going to need a 2¼ inch long bolt, fully threaded. Oh, actually, we only need it partially threaded. We're going to go all the way across here to this right there, that number right there. And then once we hit that number, we get this product detail right here. And then we hit that little thing right there that says CAD, and it brings us up to this. And when we go down here, we'll go to 3D SolidWorks. You just open this and you put it in 3D SolidWorks, and you're going to go ahead and save it. All right, so once we've got our parts, we can go ahead and insert them. We have to browse for them. In my case, it's in my downloads folder. So I'm going to go ahead and open that. Oh crap, I messed up. I need to put down the push pin. Push pin. All right, I need that guy in there. Open. 1, 2, 3. There's my 4th one. Then I'm good. And I don't know why my bearing is taking so long to open. But while we're waiting on that, I'm just going to add a little bit of a note. So normally, in the regular season, we wouldn't have to put in bolts and nuts and washers and all these stupid things. We'd need to put in bearings. Bearings are regular. But we wouldn't need to put in bolts or wires or chain or belts. because we don't care. We know what bolt it is. We can just look at the size, and I mean, we probably already have it. But this is different. In F4 Catathon, we're trying to make it look as good as possible. So we need to put in everything, like everything. If it's going to be on the robot in the final stage, we got to put in the CAD. So that's why we're putting in bolts, why we're going to have to put in some nuts. We don't need to put in washers right now because this is literally solid aluminum. But if we're trying really hard, we can. So we're going to go ahead and select that. Select that. Let's make that concentric. It already defaulted to that. And we'll select that face. And we'll select that face. And I'll make it coincident. And then what I can also do is, instead of selecting the circles on the bolt head, I believe I can select that circle and that circle, and I can make that concentric. And so then I'll go ahead and select that. Actually, what I'm going to do is I'm going to make all the bolt heads coincident, so they're all on the same plane. That way, if for some reason something changed, at least all the bolts would be within the same thing, because I don't see the bolts changing anytime soon. So then we'll bring this all the way over here. Bring this to, oh, I already screwed up. So if you select the wrong thing, you can go over and, oh crap, where'd it go? What? Dude. Oh, there we go. So you can see your mate selections right here. If we right click this right here, we have two options. We can either clear our selections or we can delete it. If you have multiple things, you'll probably just want to delete it, but since it's only one thing, we can just do either or. So then we'll go ahead and select what we want to do, which is that face right there and that face right there. It's good. And then that guy right there and that guy right there. All right, cool. So now all of our bolts are in. Great. Now, actually, now we're going to go ahead and just put nuts on this. We don't even need this right here. We're going to go ahead and delete that. So we'll just put nuts on these four right here, and then we'll put a bearing on either side. So now what I need is, where's my freaking bearing that I downloaded? Downloads. Okay, there it is. Oh, I know why. If I go to Insert Components and I browse, you can see that the default here is SolidWorks files. So those are slide parts and slide assemblies. What we need is any file, or we can do step files if you know what it's in, but we're just going to go ahead and look at all files. And then what we have right there, that is what we need. Then I'm going to put one on either side. Boop and boop. All right, there we go. And this is why I like to use move with triad, because then I can tell that to go, yep, I want you to go to right there. And yep, I want you to go right there. And if you put your cursor over here, you can change minutely how far you want it to go. But if you drag in your cursor to around this ring here, it'll snap. to these different ones. So we'll go ahead and go with 90. And we're going to go ahead and mate these bearings to the main block. Make that concentric, sorry. Coincident. Go ahead and do that with that. And made it like that. Okay, now cool. We have this going. Problem is, if I went, now well, they are, but if I went like that, now my hex profiles aren't lined up. And if I went and put in my shaft, then everything would be kind of wonky. Oh my golly, I'm voice cracking so bad. But what we're going to go ahead and do is we're going to make this right here to that right there. And that way, whenever we rotate them, they move together. It's just little things like that that are going to stand out. Whenever they open something, you don't want all your bearings being wonky and your gears are out of whack or something like that. And so you want them all to be kind of running in tandem. And so now we're going to actually put in a shaft. So we're going to go back to Vex Pro because I like them more, because they're better. I'm going to go to shaft stock. So we're going to go ahead and grab some 1/2-inch hex stock. Drawings, CAD files, there we go. So we don't need that. We're just gonna do some regular hex. So download that right there. Now, let's say for this, I need my hex axle to be 6 inches long. Okay, so we're gonna go ahead and open it. Hex stock. It's loading. All right, cool. No, I don't care about import diagnostics. I might in the future, but I don't. So now we got to make this 6 inches long. This is very obviously not 6 inches long. This is 18 inches long. So obviously the answer here is to go from one end and to just chop it all off, right? Wrong. That's not what you want to do. What we want to do is a little thing that's very, very useful. It's a little checkbox, but it makes all the difference. So we're going to go ahead and make a nice pretty rectangle. It really doesn't matter how big it is, as long as those are the same edge. We're going to make those collinear. So those are now the same edge, they're overlapping. Then we're going to make this, is that in freaking millimeters? No, it's in inches. I don't know why it keeps showing up as freaking millimeters. Frick, Ryan, you were wrong. 6 inches. All right, cool. Why are you in freaking millimeters? I guess because you're freaking stupid, I guess. What the heck? That's stupid. Okay, rant aside. I don't know why it's doing that. It's stupid. But we're going to go ahead and fully define this. All we need to do is change this distance to be something big, like 2 inches. And then, I mean, this is going really far, but we're going to go ahead and draw a line here. We're going to want that to be the very center of it. Crap. So that's vertical. These are perpendicular. Do they need to be perpendicular? No, they're already assigned as that. That thing is the midpoint of, wait, what the heck, dude? How are you not fully defined? Oh, because I need to relate it to that. Oh, Oh, because I didn't relate that to that. Okay. Well, that's stupid. I don't want to do that. You know what? That doesn't even matter. We're going way too far for this. This is literally just a cut. So what we're going to do, this says 6. This is 6 inches. We're going to say it says 6 inches. We're going to go to extruded cut. And it looks like if we do through all, that we're going to cut off 6 inches. Well, what the heck does that do for us? Absolutely nothing. That's why you do flip side to cut. Boom. What that does is it leaves 6 inches. Boom. That's called CAD magic right there. All right, so we're going to save this. Save as. We're going to do it in documents. Where did I put it? I put it as F4. X. All right, now that we have X, going to insert hex into our assembly. We're going to, this is where you'd use like tangent if this were just like a regular hole and something stupid, but we can literally just make all these sides coincident. And then if we want it to be a certain distance from the edge, we can do that. And you can set this distance. Why are you in freaking millimeters? Oh my God. Oh my God. Sorry. This is going to be 2 inches. So if you can't tell already, whenever it's in millimeters, because it's stupid, that's why. I can just hit 2, and it can either give me units, can do that right there. Bada bing, bada boom. All right, there we go. There is our magic thing. But wait, we forgot our nuts. No. All right, and we're gonna go back. We're gonna go over to, by the way, I hope you're all doing this on your own CAD things. Nuts. Hex nuts. Medium strength. I need 1032. Crap. Crap. See, that's the problem with McMaster Car. It's like, what the heck, dude? 1032. So on the side here, you can select different things, or you can go over here if you know exactly what the name is. You can just select exactly what you want. So we can go ahead and select this. It's literally just a nut. Product details. Yeah, save. Cool. Insert components. Browse. Gosh. Low strength. Yada, yada, yada. Crap, I forgot to push down the push pin. That was my fault. I do that every time. All right, there we go. We're going to go ahead and make these. Cool. I was just banking on the fact that I was hoping that those were going to be concentric. Let's try a different circle. Can I make that? Ah, dude, that's so dope. There might be, ooh, can I mate these with the thread? Thread and thread. No, I can't. Undo. This is the undo button. If you do something stupid like I did, and then you try to do it, then you can undo it. We're gonna go ahead and make that concentric. And then coincident. Screw Ryan. Ryan's always wrong, except whenever he's right, which is most of the time. Did I already do that one? No, I did not. Boom. And then I did not make that concentric. And then go ahead and make that coincident. All right, we are finally done. This is our weird piece that means literally nothing. And it looks really ugly. But it was a valuable step in the right direction. That's why we're going to save as, save all, a step in the right direction. Boom. And we're going to put it in documents. Where's F4? There's F4, open. Boom. A step in the right direction. I'm really witty. All right, now don't go yet, because what we have to look at is we have to look at the naming system. So we went over most of the stuff that you'd have to be doing with your, oh, someone talked in chat. I joined a couple of minutes ago and probably missed a lot. Yeah, you kind of did, sorry. What have you guys been discussing? Assemblies. Luckily for you, I have been recording this the whole time. And I can send that to you, and I can send that to other people who get interested late, because I did set the deadline. Actually, I did set it to be today. Huh. Anyway, so I can send it to you, and you can get caught up through that. You might have picked it up from just what we were doing. But yeah, sorry about the impromptu meeting. But you can go ahead and look at this whenever I put it up on the thing. Hide that. Okay, so the last thing we're going to go over is we're going to look over how we manage things. If I go to document, okay, no, wait, back to downloads. Okay, so I just downloaded these 4 things. Now, the problem is these are in my downloads folder. These are not in my F4 folder. And what you're going to learn later is we do everything through GrabCAD. And so if I were to do this, none of these 4 parts would get uploaded to GrabCAD. So if I wanted to reference, like if I wanted to open up another half-inch hex bearing, I wouldn't be able to open up that part. If I wanted to modify that hex stock to be, if I wanted to modify the hex stock to be like 5 inches instead of 6 inches, then I would be out of luck, because I wouldn't be able to open it because someone didn't save it properly. So we're going to go ahead and select all these. And we're just going to shove it in our F4 folder. Try again. Oh, crap, it's already in my SolidWorks. Okay. So then I'm going to go ahead and close all my things. These should be already saved. Try again. All right, there we go. Now all my parts are in the F4 document. And that thing you saw, it was just because I had the files open. I couldn't modify the things with them in the file directory because they were already open. It's just a weird thing. If I want to rename these, and we're going to be using a naming system. I'm going to call this MX. Wait. I'm going to come up with a better name than MX 1.0 because this is probably not going to be the first F4 competition that we do. And I don't want to call it 1.0, 2.0, 3.0 because that's kind of dumb. But it's going to be MX 1.0. And then we're going to call this, it's going to be part of the first subassembly. So it's going to have a 100. And then it is going to be part of the first subassembly. So it's going to have a 1 in the tens place, and it actually is going to have a 0 in the tens place. And it's going to be a 1 in the ones place because it's the first part that we're using. Boom. Save as. And then for this, we're going to rename it to MX 1.0 102 dot slide part. MX 1.0, it would be like Marvin. We usually do like, crap, what was last year? It was like 13 or something Roman numerals. I don't understand them. But we have a little bit of a naming. This MX thing is just what we do for our off seasons. So we're going to rename this as 100. 100? No, it's 110. I'm silly. Crap. Rename MX 1.0 110. Okay, so after you give it these fancy numbers, you're going to describe what the heck it is. I literally don't know what this is, so it's going to be the bearing block assembly. That's what it is. We can go back and we can rename this. It's going to be 112 bearing block. Then we can rename this 110, or sorry, 111, and that is practice block. And if we go over to our hex piece, we can rename this MX 1.0 113, and this is we're going to call this, what mechanism is this powering? We're going to say this is part of the drive transmission. So this is the drive transmission axle. No, it's the bearing block axle. Boom. What I don't want to be doing is I don't want to call this 6-inch axle because that's obviously something that might change in the future. Maybe I'm not going to make it 6 inches. Maybe I'm going to make it 5.999. Or something of more value. But you don't want to put dimensions in here, just like descriptions of what they are or names of what they are. And then use this numerical naming system. And then what we'll do in build season is we'll have like bearing block. And we'll take all these and we'll put them in bearing block. And that's the general thing that it would be. Now, this is, we'll generally not make a whole folder for a freaking bearing block. Usually we'll put a whole folder as, here, let me go over to, actually that's a terrible example. Let's go over to this one. So we can see we have all these freaking folders, and then we have very few actual things that are loose here. We have this stupid thing, I don't even know what that is. It's probably actually really, really useful. This is a design calculator. I think I'll actually go ahead and go over this, maybe. I don't know if I'm going to go over that. If you guys want, we'll have another class tomorrow, in which case I go over this and some design things at the early design level with like large scale sketches and things like that. I don't know what, this is really, really important. We'll also go over this tomorrow. Yeah, we're gonna probably have to go ahead and do something tomorrow. Power up score calcs. I also don't know what that is, but that's the main assembly right here. And it is 0001. This is the most important one. Now, if we go over to, I believe chassis is 100s. Oh, it's actually in the thousands, sorry. Wait, that's wrong. No, it should be only in the hundreds, right? Am I going crazy? Yeah, it's only in the hundreds. Sorry. Yeah, if you go over to chassis, you can see like these are the main folders, and then it's Mars 1003, and then it goes over and talks about the thing, and you can see all the different things. Now, something we don't do that I'd love to see in the future with Mars is maybe let's try to make like show progress over time and design iteration. That would literally just be someone downloading the whole GrabCAD folder and copying it over to something else and then making a backup of it every once in a while. But I think that's something that we might want to do for this. We might want to show our design process and see how things change over the course of the week. Now, it's obviously not going to change as drastically as it does in the regular season, where we go from like a mechanism intake to what we did after Palmetto, which was like the V, what I call the flying V. It won't change probably that much drastically, but we'll see. It might be fun to see how we change our design focus over the course of the week. But let's see. I think that's all I needed to cover for this. I showed you how to download things. I showed you how to use assemblies. Yeah, I think that's about it. So if you guys have any questions, please let me know right now. You can also talk to me through direct message in Slack. But yeah, just let me know what you think. I'm gonna put this up on the Slack, so you'll be able to see this. But yeah, do you have any questions about this? Do you have any questions about F4? Do you have any questions about Mars in general? What the whole catting thing is about? Ask away. All right, cool. I guess it's a good thing there's no questions. I'll just assume that you guys know everything. Cool. I'll just decide. We'll probably have another meeting tomorrow, and then with that, we're gonna go over like assembly features, some of the large scale component mapping with whole robot sketches and things like that. But yeah, I guess if there's no questions, then that's the end of the meeting. Bye-bye.